In this video, we will interpret code using AWS Bedrock and LLM foundation models. So in addition to the standard AWS libraries, we are going to use LangChain as well. So here we are importing standard Python libraries, and then we are importing a couple of utility functions. The code for these functions is from AWS Bedrock workshop. The link is in the description below. So using this Bedrock, here we are creating two clients. One is the standard Bedrock client, and the second one is the Bedrock runtime. Okay. By default, we don't need to provide the region, but since the Bedrock is not available in all the regions, here we are providing a region where it is currently available. Okay. All right. So we have created two clients. Now using the standard client, we can list all the foundation models. They contain lots of other information. So here we are printing only the model IDs. So these are all the models supported by the Bedrock. All right. And then, so from LangChain, here we are importing the Bedrock, and here we are creating the instance of our LLM model. Now, in order to do that, we need three things, right? One, which model we want to use. So in this case, it's Anthropic, the Claude V2 model from Anthropic. And because since this model is from AWS Bedrock, we also need to provide the client. So this time it is this Bedrock runtime. And the third argument, it's the LLM model parameters. Okay. So the parameters are typically the maximum number of tokens, the temperature, top K and top P. So these three are related to how the next word is selected, but these are not so important for these kind of tasks. So leave them as it is. The important one is this maximum number of tokens. So choose a number so that your code, depending on the level of details we want, we will choose the maximum number of tokens, because that will determine the output length as well as the cost, right? All right. So all we did is we just imported this Bedrock function from LLMs, LangChain, and then here we have instantiated our LLM model by providing the model ID, the runtime client, and these optional parameters. Okay. All right. So here we have some sample code. We'll come to it in a bit. But let's say once we have the sample code, then we need to create a prompt to provide to the model, right? So we are using this prompt template so that we can reuse the template. So here we have two variables. One is code and the second one is programming language. Okay. So our template, this is how it looks like. So here we have a human, and then we have this LLM assistant. So here we are going to provide our input code as well as the programming language. Now we don't need to strictly provide the programming language because the LLM can interpret what language it is. But if you want to have some, let's say the metadata, or let's say this application is integrated within some system where we want to keep track of the programming language, etc., we can provide that argument as well. Okay. So here we are saying you will be acting as an expert software developer in a particular programming language. So we will be providing what that programming language is. And then the task is you will explain the below code and highlight if there are any red flags or where the best practices are not being followed. Okay. So there are sort of three tasks, right? Explaining the code, highlighting if there are any red flags, and the best practices, checking if there are any best practices or not, right? So here we have created this prompt template, right? So this is the prompt template. This is multivariate prompt, multivariable, since we have these two variables, right? So now we create the actual prompt using this prompt template, right? By providing the two parameters. One is this code and the second one is the programming language. Okay. So here we already have the code. So our code gets substituted here and the programming language gets substituted here. So this is going to be our prompt, right? So by using this prompt template, we can reuse them. All right. And then here we are actually calling the LLM, right? So this will invoke the endpoint. This will invoke this model endpoint using the Bedrock runtime. All right. So that's it. So we simply provide the prompt and then we get the response. And here we are just processing that response a little. And here we are printing the output. Now let's have a look at the code. So here we have some C++ code. The code itself is not complex, but it is using some important concepts from C language. So here we are creating a class called vehicle, and it has some protected variables as well as some public methods. So the concepts like encapsulation has followed here, and then it has some public methods, right? We'll look at them in a minute. And then here we have another class which is inheriting from the vehicle class. So there is inheritance, and here we have another class called car. This is also inheriting from the vehicle class, right? So there is inheritance. And also, because these two classes are different, there is polymorphism as well, because the base class is the same, but we are using it for two different types of classes here, right? And then here we have a bunch of functions. So basically we are checking if the number of miles, for example, this function, we are checking if the vehicle has traveled more than 10,000 kilometers since the last maintenance mile. If that is the case, then it needs maintenance required, right? And then here, if it does the maintenance, and then we are resetting the last maintenance mile to the current miles, because the maintenance has been done. And this function, it is simply tracking the miles traveled. So the new miles gets added to it, right? So those are the classes and the public, the methods. And coming to the vehicle class, yeah. So coming to the truck class, in addition to the inheritance from the vehicle class, it has this additional, it has a couple of additional variables like the capacity and the registration number. And then it has this display details function, which display the attributes of this of the object when we create, right? Like the registration number, the capacity, the tons, etc. Similarly, the car one, it also has the car model, as well as there is an additional variable. I think it has only one variable, the registration number as well as the car model, right? So that's it. And here it's been more than a decade since I used C++ language, but this seems some modern concepts for creating the instances or the objects of the class. So here we have created two objects, one for truck and one for car, with the registration number, and this is the tons, the registration number, and then the model type. And then here we are calling a few functions on these two objects, right? So first we are displaying the details, and then we are adding the miles, and then we are checking if the maintenance is required. If it is required, do the maintenance, and then things like that. And finally, we are deleting the objects. All right. So here is our output. Again, just go back to our prompt. So here we are asking, explain the code and highlight if there are any red flags, and check if the best practices are followed or not. Now, I won't go over all these comments or the output, but to me, it has done a really good job, but it focused more on highlighting if there are any red flags and the best practices. So it did not focus much on explaining the code. It has said, okay, inheritance, this encapsulation, things like that. So it is talking more about these best practices, etc. And then it said, it talked about these constructor destructor concepts as well. And at the end it said the code is well written, etc., etc., but it has some memory leakage issues because it is not using this virtual deconstructor. And it said usage of this vector when creating the objects is a modern concept, so and so forth. But these comments are not really so helpful in understanding what the code does. So then what I did is I went to ChatGPT free version, which is 3.5, and I just pasted the code and simply asked it to explain the code, right? Then it did much better job in explaining the code, right? So it said it has this vehicle class, it has this truck class, and what are the private variables that the truck class is inheriting from the vehicle class, and it has these additional attributes, so and so forth, right? So it is explaining exactly what the code is doing. That's what our intention is, right? To understand the code. And then if you notice here, it did not talk about the output from the code, right? For example, when we run this code, what will happen? It did not focus anything on this part. Whereas ChatGPT, it explained what would happen if we run the code, right? From creating the objects of the class to everything happening within those methods, right? So this is quite impressive. And then what I did is maybe because here we have asked for three things. The Claude model did not do as good job as ChatGPT. I have changed the prompt. So here we are asking only, please explain this code written in C++, right? So we are not asking for best practices or red flags, etc. But even then, it did not do as good job as ChatGPT 3.5. Okay. Again, these are more at the concepts level rather than explaining the code method by method. Okay. That's it for this video. Thank you very much.